So please label your notes 4.1 Antiderivatives and Integrals. And just as a warm-up, similar to what we just finished doing, what I would like you to do is figure out what f of x is if the derivative of f of x is equal to a few different situations. So in A, I'm going to tell you that the derivative is equal to 2x. What is the original function? So if the derivative is 2x, what was the original function?
2x squared.
2x squared?
X squared.
X squared. X squared. Good. The derivative, the original function would be x squared. Now, if you're wondering if what you're coming up with is right, work backwards. This is the original function. Take the derivative of x squared. What's the derivative of x squared?
2x.
It's 2x. So yes, you are right. The original function is 2x. What about this? What if I tell you that the derivative is equal to x? This is a little bit trickier one. The derivative is x. What would the original function have been if its derivative is x?
X squared.
It's got to be an x squared. Why does it have to be an x squared?
The power.
Because this power right here is power of 1, so that means here we had to start with a power that was 1 higher. Would you agree? So what do we have to put in front of this x squared so that we would have a 1 x?
1/2.
Good job, Ross.
1/2. And yes, and Craig, you had that a minute ago too. So it would be 1/2 x squared. So 1/2 x squared, the derivative of 1/2 x squared, 2 times 1/2 is 1. You subtract 1 from the power, you're going to have x. You're going to have just an x. All right, C. What about, what if I tell you that the derivative is x squared? What if the derivative is x squared? What was the original function?
2.
1/3.
Very nice, yes. This power is 2, which is 1 less than the original power. Would you agree?
Yeah.
All right, so x
1/3.
cubed.
1/3.
And then what would have to go in front of it so that when I multiply it by 3, it becomes a 1? 1/3. Very nice. You guys are doing really good with this. Now, for those of you that are like, really? You have to think like this every single time because you know I'm giving you the easy ones right now. I will show you some tricks along the way, okay? So don't freak out on me yet. Freak out on me later when it's okay to freak out. All right, the derivative is the cosine of x. Easy one. What's the original function? Is it sine or negative sine?
Sine.
Sine. Because the derivative of sine is cosine. Okay. Now I gotta talk to you about one more thing before we move on to more of this stuff. How do we know if the derivative is 2x? How do we not know? Like what if maybe there was a 3 at the end? What is the derivative of x squared plus 3?
2x.
It's 2x. So do we know if there's something added on to the end? No. So this is what we need to do instead. You need to, go back, I might do this in your notes. You need to go back and you need to add a plus c on the end of every single one of those derivatives, or excuse me, not derivatives, original functions. What do you think the c means? Yeah, c meaning a constant value, some number added at the end. So, pardon me?
Can it be minus c?
Yes, it could be a minus c, but this plus, it could be, the c could be negative, which would take care of the whether or not it's a positive or a negative. So you'll see it always written as a plus c at the end.
So on everything.
On everything. And the reason, well, these things are called indefinite integrals, and they're indefinite when you don't know for sure if there's that constant value added at the end of your original function. They're called indefinite integrals. All right. All right, so there's new notation. This is the notation. They're kind of fun. These are kind of fun. It looks like this. It's the integral symbol. The integral, all that means when I ask you to find the integral of a function, I'm just asking you to work backwards and find the original function. That is the symbol. It's kind of like an S, but stretched out, and it's not quite as curvy. Will I be grading you on whether or not you can draw the integral symbol correctly? No, of course I will not. But they're kind of fun to draw. This symbol right here, like I just said, stands for integral. If you see that symbol, that means that you are finding the integral. G of x, that is the function. Can someone grab the door? That the integral is applied to. And you'll see a dx at the end too. And this part right here, all that tells you is because it is a dx, that just means to you that the function was written in terms of x's. So this is the variable of the derivative. And usually you will know what the variable is anyway, because the function will have an x or a t or a theta or something in it. But sometimes if you just end up with a constant here, like they only give you the derivative as 5, this dx at the end will tell you that when you come up with the original function, you have to have an x in your function. Or a t if this was a dt or a theta or whatever. Okay. All right, let's try some examples. I'm going to start giving you guys a few shortcuts. An example of this. Let's find the integral of 3x dx. 3x dx. And I've noticed that some of you are already picking up on some of these little tricks, but what I would like to just mention to you is when you have a constant number right out in front, that is the same thing as writing this as 3 the integral of x dx. So that constant number can always be brought right out to the front, and then you can deal with just what's left over. So all you have to worry about now is the x. What is the integral of x? Yeah, did we talk about that one on the first page at the beginning?
Yeah, 1/2 x squared.
We do the integral of x, yeah. The integral of x was 1/2 x squared. So when I ask you to find the integral of 3x, well, this part right here has an integral of what? 1/2 x squared, but then there's that 3 in front of it too. So it's not going to just be 1/2 x squared, it's going to be 3 times 1/2 x squared. So let's write that out. This is going to do the same thing as 3, and then in parentheses I'm going to just work on the integral part of this. The integral of x is 1/2 x squared. And as soon as you come up with that function, you can get rid of the dx, and you can get rid of the integral symbol too. So the integral of x dx is 1/2 x squared. I get rid of all the other junk around it. All I have left now is 3 times 1/2 x squared. All right, so what is 3 times 1/2 x squared? 3 over 2 x squared. So that is the integral of 3x. Now, I want to talk to you about some of the tricks that you can start doing. What I did here was I looked at my function that's written next to the integral symbol, and it's an x. X to the power of 1, right? Yes?
Ms. Corrigan, I'm confused about the dx part. Like, I don't understand what.
All this is telling you is that the function that you have to come up with in the end, this function right here has to have an x in it. So if this said dt at the end instead of dx, you would have, it would be 3 3 over 2 t squared.
Oh.
Okay? But like I said, in this case, you didn't even need to know, you didn't even have to have the dx there because you already know it's in terms of x's because the integral is 3x. Okay, but sometimes, like what if the x wasn't there? I just asked you to find the integral of 3. What's the integral of 3? Well, how do you know if it's an x or a t or a theta or a z or an n or a p or whatever? That's why that is there to tell you that your function needs to be written in terms of x.
So would it,
Okay?
if it was like sine or something, it would say sine.
It would say d, whatever, it would be the sine of theta probably. So it would say d theta. Okay? Yes.
Would there be a plus c at the end?
Yes. Thank you. Guys, yes, we need our plus c at the end. Don't forget about your plus c at the end. Thank you, thank you. Yes.
So if it was just 3 dx, it would still be the same answer because like you know that that x happens in 3.
No, I am saying to you, what if I asked you to find the derivative or the integral of 3? Well, this is the derivative. You need to find the original function. So if I don't give you some direction here and say dx, you don't know if when you find the original function, is it going to be 3t? Or is the original function 3x?
All I get was just
Or is it 3 theta? Because the derivative of this is 3, the derivative of this is 3, the derivative of this is 3 also. So all this is telling me is that when I come up with my original function, I've got to have an x in it.
Can you go back to the page with the integral thing?
Yep, see this dx is just telling you the variable of the derivative.
I don't understand how you got 1x over x squared. How did you get that? 3x.
Okay, this was a constant number, so I brought that out front. So I have 3, the integral of x dx. So you can ignore the 3. Just worry about finding the integral of x. So you had to figure out, how did I end up with x? What was my original function so that I ended up with x? And we talked about that in the front page, and I haven't gotten to my little tricks yet. So for those of you that are still going, I don't know how to do this, I'm so confused, we're not there yet. You guys are asking really good questions, and your questions are about 2 steps ahead of where I am, okay? So just hang tight. Are you okay with that? All right. Okay, let me talk to you about where I came up with this. This x was to the first power, right? So your original function that you're trying to come up with was to the power of 2. How do I get from 1 to 2? You add 1. Now remember, if this is what you started with and I had asked you to find the derivative, what did you do to that power? You subtracted 1. Remember that? You subtracted 1. So now if you are starting with this and you have to work backwards, now you need to add 1, okay? So the first thing that you do is take your integral and you add 1 to it. Okay? Does that make sense? You're working backwards. We used to subtract 1, now we're going to add 1. We also used to multiply these 2 numbers. What are we going to do now?
Divide.
Now we're going to divide. So we are going to add 1 to the power and we are going to divide. So I'm going to go back to this x again. This is what we are starting with. We got to figure out what was the original function. So we add 1 onto the power of 1. So I add 1 on, which is a 2. Would you agree?
Mm-hmm.
Now I have to divide by whatever new power I came up with. I came up with a new power of 2. That's what I divide by. I'm going to divide by 2. Do you see it now? So it's x squared divided by 2. What is x squared divided by 2? It is 1/2 x squared. Now, where did the 3 come from? Remember we had that 3 out front. So I just have to multiply this function by 3, which makes it 3 over 2x to the power of 2. Don't freak out on me yet, because we're going to try some more, and I promise you this is not horrible. I'm going to try another example. What about, let's do the integral of 1 over x cubed dx. Now, all that this dx means to you is that when you come up with your original function, you have to have what in it?
An X.
You have to have x's. And most often, you guys, I'm going to give you x's. Not always, but it will most often be x's. And I don't even care. If I don't give you an x, use an x anyway. That is not the goal of this. What is wrong with this?
The fraction.
It's a fraction. So let's do a rewrite. It is the integral of x to the what? Negative 3 power dx. All I have done is rewritten to make it easier for us to do this. Now, the next thing I said to you was add 1 to the power. We used to subtract 1. Now we are going to add 1 to the power. Add 1 onto negative 3. Negative 2.
Oh, negative.
Add 1 means we become less negative. Confusing, I know. So this is going to be x to the negative 2 power, but I also said once you come up with your new power, you must divide by that new power. What am I going to divide by?
Negative 2.
You divide by negative 2. The only thing that you need to do now is a rewrite. Why do I need to rewrite that?
Negative bottom.
Because I have a negative exponent on the top. Move it to the bottom. So this is the same thing as negative 1 over 2x squared. So I took that x to the negative 2 and I moved it to the bottom. That does not mean that there's nothing left on the top. There is still a 1 there. The only part that gets moved to the bottom is the part that has the negative exponent. Are you okay with this?
Yes.
Don't lose your negative. I don't care where that negative sign goes. It can go on top, it can go on the bottom, you can draw it right in the middle if you want to. What else do I need to do here?
Plus C.
Very good, because there could be a constant at the end that we don't know about, so we just write it there in case. The integral of the square root of x dx. Do a rewrite. Give me a power. You got to put it in terms of powers.
X to the negative 1.
Very nice. X to the positive 1/2 power.
Oh, yeah.
Dx. Use the rule I just taught you. What do you do to that 1/2 power?
Add a 1.
Add a 1. So what is 1/2 plus 1? 3 over 2. So this becomes x to the power of 3 over 2 divided by that same new power, divided by 3 over 2, equals. Now, I'm taking a numerator divided by a fraction. What happens when I divide by a fraction? Multiply by its reciprocal. So just do that in your head. Get rid of the fraction on the bottom, flip it, and move it to the top. So you have 2/3 x to the power of 3 over 2. So really what I did was I multiplied the denominator by 2 over 3. They cancel out. And then I have to multiply the numerator by 2 over 3. So I end up with 2/3 x to the power of 3 over 2. Plus c. Thank you. I think I taught you that. But you can remind me to do it too. Okay, I'm gonna work it. Not yet. But we're getting close. Do you already feel a little bit better about it?
No. Can you give us like you keep saying like the equation, can you write it so I know it? Like plus 1.
Oh.
Is it always plus 1?
It's always a plus 1.
Plus 1 divided by the x.
Yep. But unless it's like sines and cosine stuff, which we're gonna get to next actually. You know what? I am gonna have to think about that before I just give you the rule, okay?
Okay.
Alright. Alright, here we go. Find the integral of 2 the sine of x plus 5 dx. Okay, sine. What's the derivative of sine? What's the derivative of cosine? Negative sign. Okay, so remember, we already have the derivative. You got to come up with the original. So what would the original function be? I'm just talking about the sign part right now. We'll talk about the 5 in just a minute. What would this have had to be? Negative cosine. Very good, because the derivative of cosine is negative sine, but we are ending up with a positive sign, which means that we were actually starting with a negative cosine. But there's a 2 up front too. So it's actually going to be negative 2 cosine of x. Very nice. You guys already know that, don't you? This, what is the original function? If the derivative is 5, the original function is 5x. Don't do the power rule, add 1, divide by, you don't need to do that. Because some of these things are pretty self-explanatory. So plus 5x. Plus c. Very nice.
That's it?
That's it.
Oh, wow, I like that one.
Oh, I thought she was just really
Alright, here we go. This is a little bit harder one. The integral of x plus 1 over the square root of x dx. It looks horrible, doesn't it? Doesn't it? But I just want, do not forget about, this goes back to China. Earlier today we were doing those derivatives, and you had to find their match, and you had this. You had x plus 2, or was it 3? It was x plus 3 over 2. And I said to you that that was the same thing as a half of an x plus 3 over 2. In other words, I took this 2 and I divided it into both terms, right? Stuff that you've been doing for years and years and years. Do the same thing here. Take the square root of x and divide it into both the x and into 1 and do a rewrite. And I'm going to take baby steps to get to this, and I don't want to lose anybody along the way. This is the same thing as x over the square root of x. Actually, if it's okay with you, I'm going to do this instead. I am not going to write this as x over the square root of x. I'm going to write it as x over x to the 1/2 power. Are you okay with that?
Yeah.
The square root of x is x to the 1/2 power plus, now I'm going to take this 1 and I'm going to divide it by x to the 1/2 power. So we have plus 1 over x to the 1/2 power. We are finding the integral with respect to x. Okay with that?
Yeah.
Okay, let's clean it up. We have x to the first power over x to the 1/2 power. What do you do with the exponents? What if you have this? What if you have x cubed over x squared? What do you do to those exponents? You want, that's the same thing as x cubed over x squared is the same thing as x. So what do you do to the 3 and the 2? Subtract them. So if you have x over x to the 1/2 power, you have a 1 power on top and a 1/2 power on the bottom. What are you left with? X to the 1/2 power. Very good. So this is the same thing as the integral of x to the 1/2 power plus, what can I do with this? Don't think too hard. X to the what power? Negative 1/2 power. Yep. This is x to the, move it to the top, changes the power, change the sign of the power. I gotta squeeze a little dx in there too. Gosh. Dx. X to the 1/2 power plus x to the negative 1/2 dx. Now we can find the integral. So follow your rules. Do each one of these things separately. Add 1 onto the power of 1/2. What? Add 1 onto 1/2. What do you get? 3 over 2. This is my new power. So what do I divide by?
2 over 2.
Divide by 3 over 2. All right. X to the negative 1/2 power. add 1 onto negative 1/2. What do you end up with? You end up with x to the 1/2 power. Well, what do I need to do? Divided by 1/2. Always divide by the new power. Okay. What do I do with this divide by 3 over 2?
Reciprocal.
Multiply by the reciprocal. So that is equal to 2/3 x to the 3x power plus, what do I do with this?
Reciprocal.
Reciprocal is
2.
2 over 1, which is 2 x to the 1/2 power. How do you feel about this? So? I do have one more example, but I think I'll hold off on it. We will use it if we need to. Okay.
Yeah, I'm sorry for that example.